Welcome friends, welcome to Hasib Gang. Today I have decided to talk about a very interesting topic. First of all, I will not disclose about its content. I will go through few subtopics, okay, and then I will jump into the main discussion. So let's start. Let's think that you are standing on the surface, on the Earth's surface, okay, and you have a ball in your hand. You just throw up this ball in the air. So what do you imagine? This ball will go upward, and at a certain height, after reaching it, it will return back towards the ground. Why this happens? Basically, initially the ball was at rest, and you provided some force to it. Just throw the ball, and suppose it has velocity v. So you have just so when you just throw up the ball in the air, you have put some force to it. You have provided some kinetic energy, and the ball have kinetic energy half mv square, where m is the mass of this ball and v is the initial velocity. Now the ball will go upward, and it will just move against the effect of the gravitation, the gravitational field due to Earth, and at a certain height. So let's take it is h. Its total energy, that kinetic energy, it will be converted into the potential energy, and that will be mgh. And at that height, its velocity will be zero, and then this ball will uh, start feeling the effect of gravitation, and it will go towards the ground. Here, m is the mass of this ball, and g is the acceleration due to the gravity, and h is this height. Now, just think that if you replace this ball with a light particle, what will happen? Light particles means basically, I want to say about the photon, that quanta of light, electromagnetic wave, and photon has zero rest mass. As this ball has some mass, but for photon there is no mass, zero rest mass. But now we want to check that whether this photon has some energy or momentum. Because in classical mechanics, you can see that suppose there is an object, let's take this ball, it is having some energy e and momentum p, then it will be associating with some mass m. Question is it possible for existence of a particle which is having zero rest mass, but at the same time it is having some energy or momentum? Now we want to check that. Now photon has speed, light has speed of 3 into 10 to the power 8 meter per second. And according to relativistic mechanics, whenever a particle has speed that is comparable to light speed, we have to deal it with relativistic mechanics. So relativistic mechanics is useful here. And in relativistic mechanics, there are few important things like energy mass equivalence. So if an object has mass m, it will be associated with the energy form E equal to mc square. And this energy and this mass, this m, that will be written down as m equal to m naught upon under root 1 minus v square upon c square. This m naught is the rest mass of the object. Now combining these two equation equal to mc square and this form of m mass, then we will get energy in the form of rest mass equal to m naught c square under root 1 minus b square upon c square. So this is the rest mass energy. Now in the above relations, so one thing there is for momentum there is another relation p equal to m naught v upon under root 1 minus v square upon, where in each case v is the velocity of this object and c for the light. Now when v less than c, very small compared to speed of light, so we can treat that normal classical mechanics, and according to that, the above formula for energy and P, it will turn out as equal to m naught c square and P is m naught v. Now you can see that if you put m naught equals to 0, then this energy and momentum will be also 0. So in classical mechanics, if a particle has some energy E, momentum P, then it will definitely it will be associating with some sort of mass. But if in relativistic mechanics, what happens? Just uh, we need to check down. So let's put down some equation number 2 here. This is 1 and this is 2. Now squaring E and P, energy and momentum, we have found an equation like E square equals to P square C square plus M naught square C to the power 4. Now put down M naught equals to 0 here and you will get A equals to PC. So even though that mass is 0 for this photon, there is a relationship between energy and momentum. Now, how could we so sure that this particle photon has some energy or momentum? We can visualize it through the interaction of this light with matter. If light is fallen on the material, then it will interact with the nucleus and electron, that consequence of this matter, and it will happen that the incident energy of the light that changes. So initially, if it is having some energy h nu, then after this interaction, it will have some energy h nu prime that is lower than this h nu in general. So this is the confirmation that this light photon has some energy or momentum, or it can exchange with them. It can exchange this energy and momentum with this matter. Also, suppose there are electronic labels inside the matter, and these are the different labels: ground state, excited state, E1, E2, and now some photon that is incident on this material. So the electron, it will take this photon energy and it will go towards it will make some transition. So after that, it will happen that the photon energy that is used to in this transition. Now let's get back to the previous question that what happens. First make the scenario first. So this is the earth surface and you are standing on the earth. Now you have torch in your hand and you have just turned on this light. So what will happen? Light will come out from this torch and it will go upward. If you place some imaginary plates here, you can see there is a spot in this plate. So that means light photon is going upwards. Now the question is what will be the effect of gravity on this light photon. It will be same as it was for this other object, that it will fall down after reaching some height. So we need to check that. So first, look at the energy profile. So initially, suppose this light photon has some energy here at the surface, h nu. Here the potential energy is zero, because we can choose the potential energy at the reference level zero. Now suppose it reaches some height. This is the height h. So at this height, uh, let's take its energy is h nu prime, different energy, and here its potential energy is mgh if this light particle has mass small m. Now, how this small m is coming? We have already told that this light photon has mass, rest mass is zero. So basically, it comes from the energy mass equivalence formula. So whenever this any particle has some energy E, it is associated with a mass, and this mass is the inertial mass, and basically that can be affected by gravity. Now this photon has this mass m, and this is the potential energy mgh. So let's write down the conservation law. It will be h nu, the initial energy, and after that it will be h nu prime plus mgh. Now h nu prime will be h nu minus mgh, and the m will be e upon c square, e upon c square gh. Now h nu prime finally it will turn out to be h nu, and e is basically that h nu. So it will be 1 minus uh, gh upon c square. So you can see that the final energy or even the frequency nu prime, that is basically decreases from the initial energy or initial frequency nu. So I have tried, although I have explained and computed this from a basic conservation law, but the things are not that much straightforward. This can be extracted from the general theory of relativity, and that is very complex itself. So basically, what happens? So there is a space term, space time is there, and an object is placed inside it. So there will be curvature in this space time, and the curvature, that distortion in space time, that will depends on the mass of this object. So this is basically one mass. This is the source m1, and if you put another mass m2, so it will feel this effect of this curvature, and it will just roll down. So you can also know that the gravitational force, that F is equal to g m1 m2 upon r square. So those things are there. Now let's talk about another astronomical effect. There is a star. There is a star, and it is radiating. So what will happen? It will give some radiation that will have some characteristic frequency or wavelength. So at the surface there is a frequency, but you can see that as it goes away from this surface, this frequency changes. So basically its frequency decreases, and it's also verified from this equation, h nu prime equal to h nu 1 minus. It is basically decreasing. Frequency decreases, that means lambda increases, that wavelength increases. Um, and this is called gravitational redshift. Why redshift? Because if you follow this electromagnetic spectrum, you can see that from blue to red, there's this wavelength increases. So that's why it is whenever the wavelength changes, it goes to the higher spectrum, wavelength spectrum. This is called redshift. And There is another the Doppler redshift is different from that, because in Doppler redshift we can see that wavelength changes due to the relative motion of the source and observer, and here it is just due to the gravitational effect. So I think you have understood this. I have tried to make it in a concise way. Let's wrap up the video up to this. If you find this worth, please like the video, share it, and don't forget to subscribe to this channel if you haven't subscribed. Please take care and please keep support.